Hello everyone. The title of this video is Using Synthetic Division to Divide Polynomials. Alright, so every example I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry textbook, section 5.4 called Dividing Polynomials, and I'm under the heading Using Synthetic Division to Divide Polynomials. Alright, so each example I'm doing is either going to be one of the examples from the reading, or one of the try it problems from the reading, or one of the exercises at the end of the section that are related to this particular objective. Okay. So using synthetic division. Now they go through here and give you an example. Remember lawn division and I did a previous video from this section on lawn dividing polynomials, lawn division. And I'll show you again. But there's certain cases where you can do little shortcuts using just the coefficients of the polynomials. And this shortcut is called synthetic division. And I'll read this here for you. Synthetic division is a shortcut that can be used when the divisor, right, remember the divisor is the polynomial that you're dividing by, right, like the denominator of a fraction. When the divisor is a binomial in this form, x minus k, where k is a real number. In synthetic division, only the coefficients are used in the division process. But look at this, right? This right here, x minus k. Oh, stop it. But that's important. You can't use synthetic division with any other divisor. The divisor has to be a degree 1 polynomial with a leading coefficient of 1. Right? Notice this is just x. It's not 2x or 3x or 5x. Right? And they even mentioned that back up here too, earlier in the reading. Synthetic division, a shorthand method of dividing polynomials for the special case of dividing by a linear factor whose leading coefficient is 1. So like x plus 2, or x minus 3. You're dividing by a degree 1 with a leading coefficient of 1. And then they have some steps here, but I'll leave these to you to read. I'm gonna show you the way I was taught. It's it's the same process. The only difference between the way I was taught and the way this has is the look of the synthetic division symbol. So use either one, the one I'm showing you or the one the book shows you. It'll work either way. Okay. So my first example, we're asked to divide 3x cubed minus 2x squared plus x minus 4 by x plus 3. Now I'm going to do it like I did in the last video with lawn division, because this isn't wrong. I mean, you're still asked to divide, so you can perform lawn division if you want. There is absolutely nothing wrong with that. Right, so let me set up the division. So I'm going to kind of fly through this one, as I'm assuming that you know how to do lawn division at this point. So 3x cubed minus 2x squared plus x minus 4 is the dividend, and the divisor is x plus 3. So I divide the lead terms, right? That'd be 3x squared. Then multiply by the divisor, we get 3x cubed plus 9x squared. Then subtract all of that from the line above it. That gives me negative 11x squared. And plus x minus 4 still. Then start over, divide the lead terms. We'd have minus 11x in the quotient. Multiply the minus 11x by x plus 3, we get negative 11x squared. and then minus 33x, and subtract all of that. X minus negative 33x would be x plus 33x, that's 34x. Then you still got the minus 4 here. And then finally, dividing the lead terms, you get positive 34. Multiply the 34 by x plus 3, you got 34x. Then 3 times 34 is 90 plus 12, that'd be 102. And subtract all of that. And negative 4 minus 102 is negative 106, right? So this was the quotient, right? This was called the quotient. And after all the division was done, right, this number here, after the last subtraction, that was called the remainder. Alright, and remember one last thing I pointed out in the last section that I want to bring back here is that the dividend, right? The dividend, what you're dividing into, the polynomial inside the symbol, should be equal to the quotient multiplied by the divisor, or the other way around, divisor times the quotient. It doesn't matter. A times b is the same as b times a, right? And then plus the remainder. Right? And again, it doesn't matter if these are switched. Right? Quotient times divisor, divisor times quotient, and then plus remainder. So the way we would check this is say, hey, is 3x cubed minus 2x squared plus x minus 4, is this equal to, x plus 3 times 3x squared minus 11x plus 34, and then minus 106, right, or plus negative 106. Is this true? Right, you would check this out. And multiply these two, distribute the x, distribute the 3, and then subtract 106 when you're done. And it should be equal to 3x cubed minus 2x squared plus x minus 4. Right, but I'll leave that to you to check. Alright, so this was long division. Now, because the divisor is degree 1, right, it's an x to the first power polynomial. The divisor is degree 1 with lead coefficient 1. Very specific. Because of this, we can use this thing called synthetic division. Alright, so I'll show you that on the next page, how to perform synthetic division, and then I'll compare my results with the results of long division, and you'll see it's the exact same stuff. Right. So synthetic division. Once again, it is only used when the divisor is a degree 1 polynomial with a lead coefficient of 1. Very, very specific. Right, I'll write that again here. Divisor must be x minus k. It must be in that form. Now, here, the divisor is x plus 3. That's the same thing as x minus negative 3, right? So the value of k, right, the value of k here is negative 3. Right, keep that in mind. Basically, the value of k is what the value of x would need to be to make the divisor equal 0. Right? X plus 3 would be 0 if x were negative 3. Right? So that's the value of k. Alright, so here's how it looks. Again, here's the way I was taught. The procedure is the same, it's just the symbol looks different. I make a big, like, sideways T, a big sideways cross shape here, like that. Then, there's like 4 sections here. In the lower left area, I put K. So that, for this particular example, the value of K would be what makes this divisor 0. The value of x that makes the divisor 0 is negative 3. Right? K is negative 3 for x plus 3. Right. Now up top, in the upper right-hand section, I put the coefficients of the dividend, just the coefficients. The coefficients of the dividend in descending order. All right, and don't skip any powers either. You'll see what I mean in some examples coming up. But if there's a power missing, like if there were no x squared term, or if that was gone, I'd still put the number 0 as its coefficient. You'll see again in a future example. So the dividend has coefficients of 3 for the x cubed term, and a space here, negative 2 for the x squared term, positive 1 for the x to the first term, and then the constant term is negative 4. All right, and then something else I do is put a bar before the constant term. Little bar separating before the constant term. And the reason I put that is to separate the coefficients of the quotient from the remainder down here. You'll see when we're done with the whole procedure, the numbers in this bottom row, between the 2 bars you'll have the coefficients of the quotient in descending order, and to the right of the bar you'll have the remainder, but I'll get to all that in a second. Alright, so here's the procedure. So the steps off to the side. First step, the lead coefficient of the dividend just drops down. Drop down lead coefficient. So this 3 here just gets written again down here. 3. Then you multiply by k. So here's what I mean by that. Take the number I just wrote, gonna multiply by k. Negative 3 times 3. And you're gonna write this result above the next column. Write result above next column. So, k times 3, negative 3 times 3 is negative 9. So I write that here. Then add the next column. So negative 9 plus negative 2, that's negative 11. So that's going to go down here now. Negative 9 plus negative 2 is negative 11 in the next column. And then repeat until done. So I start over, repeat these 2 steps, multiply, add, multiply, add, multiply, add. So now I multiply negative 3 by negative 11. Put that above the next column. Multiply by k. Negative 3 times negative 11 is positive 33. Then we add 33 plus 1 is 34. And then we do it again. Multiply by k, negative 3 times 34. This goes above the next column, which is the last column. Negative 3 times 34 would be negative 102. And then we add those numbers in the last column. Negative 102 plus negative 4 would be negative 106. Right. Now once you are finished, these numbers I wrote in the second row here, these numbers in between the bars, these are the coefficients of the quotient. In descending order. And then over here, to the right of the bar, the negative 106, that's the remainder. I know there's a lot of words all over this, but I'll be doing plenty of examples with a lot less clutter. So what we're seeing from this is that the quotient is, starting, again, if it's in descending order, that means the last term is a constant. So I got positive 34, got a negative, then just keep raising the power. Negative 11x, and then positive 3x squared. So the quotient is 3x squared minus 11x plus 34. Well, hey, wait a minute. Remember when I did long division? 3x squared minus 11x plus 34. When I did long division, that's exactly the same quotient I got. And the remainder, looking after the bar, was negative 106. Which, hey, look back when I did long division, exactly the same thing. Negative 106. So, putting it all together, we can say that 3x cubed minus 2x squared plus x minus 4 is equal to, the divisor. Now, another thing that's nice about this second row is it gives you another way to write the dividend, right? The dividend is this 3x cubed minus 2x squared plus x minus 4. If there's a negative 3 here to the left of the bar, that means you were dividing by x plus 3, right? Remember, it's x minus k, and if k is negative 3, that means you were dividing by x plus 3. So the divisor, x plus 3, right, that's what that negative 3 represents, x plus 3, times the quotient, 3x squared minus 11x plus 34, and then plus the remainder, plus negative 106. And this is exactly what I wrote on the previous page as well, when I did long division. You get the exact same information, but in a much more condensed space. All right, there's a lot less writing to do here than there was here. All right. But I end up with the same result. But yeah, be careful though, right? Be careful. You can't just use synthetic division whenever you want. One more time, the divisor has to be a degree 1 polynomial with a lead coefficient of 1. Right? Divisor must be able to take this form, just x minus k. All right. Okay. So let's do this again. I got a bunch of examples for you. I'm just going to keep repeating this process. Now, the next example, same thing. The divisor, what we're dividing by is degree 1, lead coefficient of 1. All right. So we can use synthetic division. Right, the divisor is x minus negative 1 technically, right? So the value of k is negative 1 when the divisor is x plus 1. Okay, so I make this big cross thing, big sideways T thing, right? In the lower left corner, I put k, which is, -1 if the divisor is x plus 1. Then in the upper right section, I put the coefficients of the dividend, the numerator, in order without skipping any powers. So positive 6x cubed, then negative 10x squared, then negative 7x to the first, and then the constant's negative 15. Then, like I did in the last example, I put a nice big bar here, separating the constant from the rest of them, and that bar will separate the quotient coefficients from the remainder. Now the steps. The lead coefficient, you just copy it, 6. Then we multiply by k, so -1 times 6 is -6. You write that above the next column. Then add -6 plus -10 is -16. And then you start over. Multiply by k. -1 times -16 is +16. Put that above the next column. Then add 16 plus -7. That's just 16 minus 7. That's +9. Then again, multiply by k. 9 times -1 is -9. I put that above the next column. Then we add -9 plus -15 is -24. And we're done. Alright. So according to this, the quotient when we do this division would be, this is a, 9. This would be 16, -16x, and 6x squared, right? It increases in power from right to left, decreases in power from left to right. It'd be 6x squared minus 16x plus 9. And the remainder would be -24. Now, if you want to, write the result, say the whole dividend equals divisor times quotient plus remainder thing, it would be the following, right? So, 6x cubed minus 10x squared minus 7x minus 15 should be equal to, and then just read across this row. If there's a -1 here, that means the divisor was x plus 1 times the quotient, which is coming from here, 6x squared minus 16x plus 9, and then plus the remainder, right? Plus -24, just minus 24. And check this, right? Check this out. And you saw me do this in the last video, again, if you've been watching. So you multiply these two and then subtract 24, and you should get the dividend back. All right, but I leave it to you to check that, though. All right. Great. And yeah, all they're asking for is like the quotient and remainder in a lot of these problems, but I personally would like you to write out dividend equals, quotient times divisor, divisor times quotient, plus remainder. And there's a reason I want you to be able to do this, right? When we get into factoring higher degree polynomials in a later video. Okay, so far, all right, it's just been a couple examples, but so far, the divisor has been a degree 1 with a lead coefficient of 1, so we could use synthetic division. But what if it's a degree 1, but the lead coefficient's not 1? Right, well, it's easy to fix. So like this example here. You have 9x cubed minus 9x squared plus 18x plus 5 divided by 3x minus 1. So I can't, right, this is degree 1. It's a degree 1 divisor, but right, the lead coefficient is 3. Right, the lead coefficient is not 1. Well, that's easy to fix. All right. especially if you write it as a fraction. Watch this. So you got 9x cubed minus 9x squared plus 18x plus 5 divided by 3x minus 1. If you just multiply the numerator and denominator of this by a third, right, multiply by 1/3 or divide by 3, right, because the lead coefficient of this is 3, that's why I'm multiplying by 1/3. Basically divide each of them by 3, right, every single term, and we get the following, right? A third of that would be 3x cubed minus 3x squared plus 6x. Now, unfortunately, you're going to have a fraction up here, plus 5/3, right, divided by, and then down here, multiplying by a third, you get x minus a third. All right, now the divisor is in the form x minus k, right, where k equals 1/3. Right, k is a third here. So now we can use synthetic division. Right, you can't use synthetic division here with the 3x minus 1 as a divisor. So unfortunately, we're going to be working with some fractions here. But you can't use synthetic division here. But after multiplying the dividend and divisor by a third, or dividing the dividend and divisor by 3, same thing, you put it in a form that you can use synthetic division. Right? And oh well, you're working with fractions, they happen, okay? So I make my little cross symbol. Lower left corner, again, the k, the 1/3, right? And then up top, the coefficients of this new dividend, right? The dividend where I can use synthetic division. I have 3x cubed, negative 3x squared, positive 6x to the first, and then positive 5/3. Right? Again, fractions happen, unfortunately, but you should still know how to deal with them. And a bar separating the quotient from remainder down here. All right, so then the steps, the lead coefficient just copied down. Then I multiply by k. Now 1/3 times 3 is 1. 1 plus negative 3 is negative 2. 1/3 times negative 2 is negative 2/3. Right, now you gotta be careful. Negative 2/3 plus 6 is negative 2/3 plus 18/3. Right? Remember, when you add, you need a common denominator. Right? When you add, you need a common denominator. So that'd be 16/3. When you add negative 2/3 and 6. Then 1/3 times 16/3 is 16/9. And 16/9 plus 5/3. 5/3 would be 15/9. Right, times 3 over 3. So that's 31/9. All right, for the remainder. Okay. So we have our quotient remainder. So basically now we can say that 3x cubed, I'm using this version here, right? 3x cubed minus 3x squared plus 6x plus 5/3 should be equal to x minus 1/3 times, and then these numbers in between the bars give me the coefficients of the quotient, which again would be degree 0, 1, 2, be 3x squared minus 2x plus 16/3, and then plus the remainder, right, plus 31/9. Okay, Now here comes, I guess, what you could say the tricky part. You know, if you felt like working with all the fractions wasn't tricky enough. You know, if you were to do long division here, this wouldn't be the result. You know, the divisor is x minus a third here. Here the divisor was 3x minus 1. So remember how earlier I divided everything by 3? Now we multiply both sides by 3 to get it back to working with the original. Right, to get it back to working with the original divisor of 3x minus 1 instead of this divisor of x minus 1/3. So now I multiply everything by 3 to get back to original divisor. Right, again, that's just to undo the fact that I divided everything by 3 earlier. I hope that makes sense. And I'll do other examples like this, but multiply by 3 on both sides. Right. Now, over here, right, when I multiply everything by 3, I'll get the original dividend. Right, 9x cubed minus 9x squared plus 18x plus 5, right? That's the original dividend. And then multiplying this, now there are two terms here. There's this product and then this product. All right. Now multiplying this by 3, you know, you pick a factor. I'm going to pick this factor here, multiply that by 3, it'll be 3x minus 1. There's your original divisor, right? So I have the original dividend, the original divisor, and then the quotient would be 3x squared minus 2x plus 16/3, and then plus, and then this is another term over here, right? There are every term is a product. 31/9 times 3 will be 31/3, right? Okay, so the original dividend, the original divisor are now here, right? Original dividend, original divisor, and now we have our quotient and remainder, right? The quotient's still the same, right? It's this 3x squared minus 2x plus 16/3, but the remainder got multiplied by 3, right? Remainder. Right. But yeah, you gotta be careful though, right, with fractions. Right. And then if you want to check it out, right, remember you multiply this stuff out down here, multiply these two polynomials, and add the 31/3, and you should get the dividend back, right? You should get 9x cubed minus 9x squared plus 18x plus 5. But once again, I'll leave that to you to figure out. All right. So yeah. So again, I'll do this again. But when the lead coefficient is not 1, divide the dividend and divisor by that number. Like here it was 3. But then to get back to the original dividend divisor, you multiply by 3, you know, at the end. All right. Okay. All right. So let's do that again. All right. I got several of these. All right. So here's another one where my divisor is degree 1, but the lead coefficient is not 1. So I'm going to divide both of these things by 2. All right. Basically multiply everything by a half. So now we have, you know, negative 3x cubed plus 1/2 x squared minus 2 is the new dividend. And the divisor now is x minus 3/2. And now the divisor is in the form that I want. Right? Now we can use synthetic division here. Right? And then later when I write out the results, we'll multiply by 2 to get back to having the original dividend and the original divisor. I hope that makes sense. So here we can use synthetic division. Now if you don't like doing all this, you know, if this is all too tricky, just use long division. All right, just do long division and get the quotient and remainder that way. I mean, nothing wrong with that, right? Synthetic division is just a shortcut for long division. If you know how to do your long division, great, just do that then, if you're finding all this too tricky. All right, so with this now, I set up my synthetic division stuff. So we got 3 halves, 3 halves, and then up top, coefficients here, -3, x cubed, positive 1/2, x squared. Now here's what I meant by don't forget any powers. You see how there's no x to the first term? There's x squared, then there's a constant, so I'm going to put 0 for that. All right, don't skip any powers. There's a -3x cubed, positive 1/2 x squared, 0x, and then the constant term is -2. And then a bar separating the quotient from remainder down here. All right, so dropping the -3, 3 halves times -3 would be -9 halves. And then -9 halves plus 1/2, that's -8 halves, which is -4. And then 3 halves times -4 would be -12 halves, which would be -6. Plus 0 is -6. Right? And then 3 halves times -6 would be -9, right? -18 halves. And then we got, -11 when you add those. And, earlier I divided everything by 2. You're going to see in a second that the quotient will stay the same. I'm just going to be multiplying the remainder by 2. All right. So watch, right? So we have from here, right, where I could use synthetic division, we have -3x cubed plus 1/2 x squared minus 2 is equal to, right? The divisor was x minus 3 halves times the quotient would be -3x squared minus 4x minus 6 plus the remainder, which is -11. Right? Again, you can check this, multiply these, and add -11. You should get this polynomial back here. Right? But now let's go back to having the original dividend and the original divisor. So instead of dividing by 2, now I multiply both sides by 2 to get back to the original. So this whole polynomial by 2, and then this I'm just going to do this polynomial here, because again, this product, you can only pick one to put the 2 into, and that'll give me the 2x minus 3, the original divisor, but then don't forget the minus 11 as well. So then we'll have -6x cubed plus x squared minus 4, right? That's the original dividend, equals, and then multiplying this polynomial by 2, we get 2x minus 3. The original divisor, and then the quotient stays the same. Quotient doesn't change. -3x squared minus 4x plus 6, or minus 6, and then minus 22, right? I multiply the remainder by 2. Right? And here we go, right? So there's your quotient when dividing those two, and the remainder is, -22. Again, that's what the way it was originally given to me, right? The original dividend, the original divisor, the quotient is -3x squared minus 4x minus 6, and the remainder is -22. And once again, you can check this by multiplying, but I'll leave that to you. Multiply these two, and then subtract 22. You'll get -6x cubed plus x squared minus 4. I promise you. Okay. All right, so again, pretty tricky, but again, if you find it too tricky, if you find all this too tricky, just do long division. All right. If it's too tricky, do long division. And if that's too tricky, well, I don't know what to say to you. Right. Learn one of them. All right. Next example. Now we're back to just plain old. Don't have to worry about dividing and multiplying by stuff, because see how the divisor is a degree 1 with a lead coefficient of 1. So I can use synthetic division immediately. All right, the divisor is a degree 1 with a lead coefficient of 1. All right, so again, I make my little sideways cross thing and lower left corner. Now this is x plus 2, so k is negative 2. Coefficients of the dividend are 3x cubed minus 5x squared, positive 2x to the first, and positive 3. I put a bar down to separate the quotient and remainder. Then I drop the first coefficient 3, multiply by k is negative 6, add, you get negative 11. Multiply by k is positive 22, add, you get 24. Multiply by k, that's negative 48, add, you got negative 45, and there you go. And I don't have to do any I don't have to multiply the remainder by anything. All right, that is the remainder. So we have here 3x cubed minus 5x squared plus 2x plus 3 should be equal to x plus 2, right, the divisor, times the quotient, which would be 3x squared minus 11x plus 24, and then plus the remainder, which is minus 45, right? And again, please check this. Right. Now, if they only asked you for the quotient and remainder, you know, here they are. I'll just put Q for quotient, and there's the remainder, R. Okay? Yeah, pretty quick once you know what you're doing. Right. There's another one, where once again, the divisor is a degree 1 with a lead coefficient of 1. So I don't need to worry about all that dividing by stuff and then multiplying by stuff later. Right? So I can just go right into it. Now x plus 2 is x minus negative 2, right? So once again, k is negative 2. Coefficients of the numerator or the dividend are 1x cubed, 0x squared. Once again, don't forget your missing powers. There's no x squared term, so I'm putting a 0 there. And then negative 3x to the first, and then positive 2 for the constant term. The lead coefficient drops down. Multiply by k, you get negative 2. Then you add, you get negative 2. Multiply by k, you get positive 4. You add, you got positive 1. Multiply by k, you got negative 2. And then add, you get 0. Ooh. Remember what a remainder of 0 means. A remainder of 0 means that the divisor and the quotient are factors of the dividend. All right, this means that x cubed minus 3x plus 2, we know how to factor it now. It'll factor to x plus 2, right, the divisor, times the quotient, which would be x squared minus 2x plus 1. And that can be factored even further too. That's actually x minus 1 times x minus 1, x minus 1 squared. And then plus 0, but no need to write plus 0. So that means these two are factors of that, right? Once again, when the remainder is 0, the divisor and the quotient are both, factors of the dividend. The dividend can be factored, and that's important to remember. Great. Next. Example 7. And once again, the divisor. All right, the divisor is, a degree 1 with a lead coefficient of 1. So I can jump right into the synthetic division. Now this is x minus 5, so k is 5. Right? The dividend has coefficients in descending order: 1x cubed, negative 15x squared, positive 75x to the first, and then negative 125 for the constant term, and then a bar again. Lead coefficient, just repeat it, drop down. Multiply by k, you get 5. Add, you got negative 10. Multiply by k, you get negative 50. Add, you get positive 25. And then multiply by k, that's 125. And then add, another remainder of 0. How nice. So once again, the remainder is 0, meaning that x minus 5 and x squared minus 10x plus 25 are factors of this cubic. Right? So x cubed minus 15x squared plus 75x minus 125 Right, this is equal to x minus 5 times, and then these are the coefficients of the quotient in descending order, right? X squared minus 10x plus 25. And then plus 0, but again, there's no need to write plus 0. It means nothing. And you could factor it even further. This is x minus 5 squared. So this is really x minus 5 cubed. X minus 5 times x minus 5 times x minus 5 if you were to factor it completely. But this is all we're asked to do, right? Find the quotient, which is x squared minus 10x plus 25, and the remainder, which is 0. Right, I'll just circle that. And again, you can check by multiplying. Alright, so now we have an example again where I need to divide by something first and then multiply by that same thing again later, so we get back to the original dividend and divisor. Because right now, the divisor is a degree 1, but the lead coefficient is not 1. So I'm going to divide both by 3, everything by 3. And then later when I write out the result, we'll multiply everything by 3. And remember, the quotient stays the same. It's the remainder that's going to get multiplied by 3. So I divide by 3 first, so this dividend becomes, 2x cubed minus 1/3 x squared plus 5/3 x plus 2/3. Alright, lots of fractions, unfortunately, but they do happen. Divided by x plus 1/3. Alright, now I have it in a form where, we can use synthetic division. The divisor is a degree 1 with a lead coefficient of 1. Alright, so x plus 1/3, k would be negative 1/3. And then the coefficients here, you got 2x cubed, negative 1/3 x squared, positive 5/3 x to the first, and then positive 2/3 for the constant. Lead coefficient drops down. Multiply, you got negative 2/3. Then you add negative 1/3. That's negative 3/3, which is negative 1. Multiply, you get positive 1/3. Plus 5/3 is 6/3, which is 2. And then negative 2/3. Oh, look at how nice this is again. The remainder is 0. Remainder is 0. Which means that x plus 1/3 and 2x squared minus x plus 2 is a factor of this 2x cubed minus 1/3 x squared plus 5/3 x plus 2/3, right? So we got this. We got 2x cubed minus 1/3 x squared plus 5/3 x to the first plus 2/3 is equal, from this line here, to x plus 1/3 times, and then the quotient, right? 2x squared minus x plus 2. And then again plus 0, but there's no need to write plus 0. And then to go back, that's with this dividend and this divisor of x plus 1/3. If I want to go back to the original dividend and divisor, then I just multiply by 3. Right, so the left side becomes the original dividend, 6x cubed minus x squared plus 5x plus 2. That's the original dividend. And then multiplying this by 3, again, you only pick one of them. I'm going to pick this one, so we get the 3x plus 1, right? The original divisor times the quotient, right? The quotient is still 2x squared minus x plus 2. And, multiplying 0 by 3 is still 0, right? The remainder is still 0. So what we have seen here is how to factor 6x cubed minus x squared plus 5x plus 2. That factors to 3x plus 1 times 2x squared minus x plus 2. Right, and again, you can check this by factoring. Right? Don't forget to check your results. Wonderful. All right, moving on. So one more here. Well, I got a bunch more, but another one here. So this is, a degree 4 polynomial. Ooh, right. All that's going to change is, the quotient won't be a degree 2 this time. It's going to be a degree 3. Just subtract the degrees, and that'll be what the degree of the quotient is. 4 minus 1 is 3. The quotient's going to be a degree 3 this time. But notice that the divisor is a degree 1 with a leading coefficient of 1. So I can use synthetic division. This is x minus 1, so k is 1. Coefficients in descending order without skipping powers. You have 1x to the 4th. There's 0x cubed. 0x cubed. Then negative 3x squared. Then 0x to the 1st. And then positive 1 for the constant term. Don't forget the zeros for missing powers. Alright, 1 drops down. 1 times 1 is 1. 1 plus 0 is 1. 1 times 1 is 1. 1 plus negative 3 is negative 2. 1 times negative 2 is negative 2. Plus 0 is negative 2. And then 1 times negative 2 is negative 2. Plus 1 is negative 1. Okay, so x to the 4th minus 3x squared plus 1 is equal to, x minus 1, the divisor, times the quotient now, again, so this is an x cubed, 1x cubed plus 1x squared minus 2x minus 2, and then plus negative 1. So these aren't factors of that. This is not factored because the remainder is not 0. But it's still another way to write the polynomial. And check it, right? Don't forget to check it. Multiply these two. Make sure you combine like terms and then subtract 1. And you should get x to the 4th minus 3x squared plus 1 when you're done. All right. Great. So there's another one where now I'm into these ones where the dividend is a degree 4 polynomial. All right, once again, the divisor is a degree 1 with a lead coefficient of 1. So I can use synthetic division right now. Divisor is x minus 2, so k is 2. Coefficients of the dividend in descending order without skipping powers. You have 1x to the 4th, negative 10x cubed, positive 37x squared, negative 60x to the 1st, and then positive 36 for the constant term. Then drop the 1. 2 times 1 is 2, plus negative 10 is negative 8. 2 times negative 8 is negative 16. Plus the 37 would be positive 21. 2 times 21 is 42. Then minus 60 would be negative 18. Right, negative 18, yeah. And then 2 times negative 18 is negative 36. Ooh, another nice one where the remainder is 0. And again, since the remainder is 0, that means that x minus 2 and whatever the quotient is a factor of this degree 4 polynomial. So x to the 4th minus 10x cubed plus 37x squared minus 60x plus 36. This can be factored. And here's how, right? X minus 2 is a factor times, and then these are the coefficients of the quotient, which again, you're starting from here. As at the constant go up, that'll be a degree 3. 1x cubed minus 8x squared plus 21x minus 18. And then plus 0, right? Again, there's no need to write plus 0. So there's a way to factor that degree 4 polynomial. All right, so you see the key to factoring higher degree polynomials is finding basically a factor that'll give you a remainder of 0 when you divide, right? Now, how to find those things, we don't know yet. All right, we'll talk about techniques to try to figure out, what polynomials will give me a remainder of 0. We'll talk about that in future videos. All right, another one of these where the dividend is a degree 4. The divisor is again a degree 1 with a lead coefficient of 1, so I can jump right into synthetic division. This is x plus 5, so the k is negative 5. Coefficients in descending order without skipping powers, 1x to the 4th, 5x cubed, negative 3x squared, negative 13x to the 1st, and then positive 10 for the constant. drop the lead coefficient, multiply, you get -5, add these, you get 0, multiply, you get 0, add these, you get -3, multiply these, you get +15, add these two, you get +2, and then multiply -10, add another one with a remainder of 0. Hooray! So this degree 4 polynomial, x to the 4th plus 5x cubed minus 3x squared minus 13x plus 10 can be factored to x plus 5 times, and then again here are the coefficients of the quotient, which would be another degree 3. 1x cubed plus 0x squared, so no need to write that, and then minus 3x to the first, and then plus 2 for the constant, and then plus 0, but again no need to write plus 0. So here's a way to factor that degree 4 polynomial. And once again, check it out, multiply this stuff out, combine like terms, you should end up with the dividend back. Great. Another example. Now this time, and you've seen several of these by now, the divisor is a degree 1, but alas, the lead coefficient is not 1. It's 2. So this is another one of those where I'm going to start off by dividing the dividend and divisor by 2, and then later when I write out the result, I'll multiply by 2 to get back to using the original dividend, the original divisor. So when I divide by 2, these we have 2x to the 4th minus 1x cubed minus 2x to the 1st plus 1 divided by x minus a half. Alright, now I can use synthetic division with this problem here. And then we'll multiply by 2 later to get back to the original problem, the original dividend, the original divisor. Alright, so synthetic division, the divisor is x minus a half, so the k is a half. Coefficients of the dividend are 2, -1, 0, right, there's no x squared, and then -2x to the first and +1. Right? Again, don't forget your missing powers, don't forget the zeros. Drop the 2. Half times 2 is 1, 1 plus -1 is 0, half of 0 is 0, 0 plus 0 is 0, half of 0 is 0, 0 plus -2 is -2, half of -2 is -1 plus 1 is 0, another 1, where the remainder is 0. So once again we have factors. That means that this polynomial here, this 2x to the 4th minus x cubed minus 2x plus 1 is equal to x minus a half times, and then 2x cubed, 2x cubed minus 2. Alright, that'd be the quotient, and then plus 0. But again, no need to write plus 0. And then to get, now this is with this dividend and the divisor of x minus a half. If I want to go back to an expression involving the original dividend and the original divisor, we times 2 on both sides, and that gives me 4x to the 4th minus 2x cubed minus 4x plus 2, right? The original dividend equals, and then multiplying one of these by 2, we get 2x minus 1 times, and then the quotient doesn't change, 2x cubed minus 2. And there we go. Here's how you would express the original dividend as the original divisor times the quotient. And again, check it out. Multiply these, make sure you get that same thing back. Great. Alright, and now my last examples, they're really the same thing, just expressed a different way. The instructions are, use synthetic division to determine whether the first expression is a factor of the second. In other words, is the remainder equal to 0 or not? Remember, if the remainder is 0 when you divide them, then it's a factor. If the remainder is not 0 when you divide them, it's not a factor. It's that simple. So if I take this and divide it by x minus 2, well, that's a lead, that's got, that's degree 1 with a lead coefficient of 1, so I can just jump right into synthetic division. If I'm dividing by x minus 2, the k is 2. And the coefficients of the polynomial I'm dividing into, the dividend, are 4x cubed, negative 3x squared, negative 8x to the first, positive 4 is the constant. Drop the 4, you got 8, 5, 10, 2, 4, 8, no. This is not 0, right? Okay, just double checking my work here. 4 and then 8 plus negative 3 is 5, 10 plus negative 8 is 2, 4 plus 4 is 8. Okay. Not 0, meaning that x minus 2 is not a factor of that polynomial. Right. And if you want to write it the way we've been writing things, 4x cubed minus 3x squared minus 8x plus 4 is equal to x minus 2 times that's the divisor, times the quotient would be 4x squared plus 5x plus 2, but then plus 8. Right? So you can see it's not factored. All right, you got a product here, but then there's this plus 8 that throws everything off. Right. And once again, double check, multiply these two, then add 8. You should get the dividend back. Right. So not a factor, right? The remainder is not 0. That's all we're doing. I got 2 more of these and should be over. And it's all the same. It's all the same. So how about, is x plus 3 a factor of this cubic polynomial? Alright, so again, we just divide this by x plus 3. This is a degree 1, lead coefficient 1, so I can jump right to synthetic division. Now, if it's x plus 3, that means k is negative 3. And the coefficients of this, negative 4x cubed, positive 5x squared, 0x to the first. Don't forget zeros, don't forget missing powers, and then positive 8 for the constant. Drop the negative 4 down, multiply, you got positive 12, add, you got 17. Multiply, 30 and 21 is 51, negative 51. Add these, you got negative 51. Then multiply these, you got positive 153. And adding these, you get 161. Not 0, right? So, no, x plus 3 is not a factor of that polynomial there. And again, a very clear way to see that is to write it out. So negative 4x cubed plus 5x squared plus 8, right, is equal to x plus 3 times, the quotient, negative 4x squared plus 17x minus 51, but then plus 161, right? And that throws everything off. That makes you know that, x plus 3 is not a factor of that cubic polynomial. And once again, you can double check, multiply these two out and then add 161, and you should get, this negative 4x cubed plus 5x squared plus 8 back. All right, but no, the answer is no. All right, I've got one final problem. All right, one final question. Same thing, is x minus a half a factor of this degree 4 polynomial? Now the divisor is, degree 1, lead coefficient of 1. So again, I can jump immediately to synthetic division. X minus a half, the k is a half. Coefficients in order without skipping powers. 2, x to the fourth, negative 1x cubed, 0x squared, positive 2x to the first, and then negative 1 for the constant. Drop the lead coefficient. Half of 2 is 1. 1 plus negative 1 is 0. Half of 0 is 0. I think we actually saw something like this earlier. 0 plus 0 is 0. Half of 0 is 0. 0 plus 2 is 2. Half of 2 is 1. 1 plus negative 1 is 0. Aha, yes. All right, the remainder is 0. Hooray! That means that x minus 1/2 is a factor of that degree 4 polynomial. And the way you would factor it is this, 2x to the 4th minus x cubed plus 2x minus 1 is equal to x minus 1/2 times, and then the coefficients here would be the quotient, and that'd be a degree 3. 2x cubed plus 2. Yeah, we saw something similar earlier with 2x cubed minus 2, I think, but there you go. That's how you factor that degree 4 polynomial. And once again, you can check by multiplying. Multiply these out and see if you get that back, and you should. Great. All right, so that was a long one, but I'm hoping that watching me go through, these 15 examples helps you in some way when you are asked to perform synthetic division of polynomials on your own. Right, and you got to understand when you can do it as well, right? You can only do it when the polynomial you're dividing by, right, when the divisor is a degree 1 with a lead coefficient of 1, right? It's that specific. Right? And thank you very much for watching.